Okay.
Record too.
Okay.
All right, I think I can read that. The difference is that I can't blow it up, I don't believe. Oh, yes, I can.
Okay.
I can
There you
download
go.
it. Here, let me download that. Oh, yeah, no, I can do this.
Cool.
Yeah, it shows you there's more than one way to skin a cat.
Oh, for sure. Here we go.
Whoops, what happened to this one right here? That's it, yeah.
Awesome.
All right.
Yeah, there we go.
Was there a choice on how you could send this to my phone?
There wasn't, not with text messages.
Okay,
It's just,
so when you send it by email, it asks you small, medium, or large.
yeah, our actual
You always
size,
do
yeah.
large, and so okay, but I can read this
Okay, cool. And then did you get 2 more pages?
on my phone. Yeah.
Okay, because, yeah, there are a few pages with the homework.
Those over. Yeah, I see. I do see them.
Okay, cool.
Let's see if I got a bunch here. Let me start at the top
Okay.
and forward that. Shouldn't take too long to do.
Mm-hmm.
Okay, and now let me go to the second one.
Okay.
Getting them not necessarily in the right order here, but
Mm-hmm.
okay, hold on. This one's a little dark, but I think I can see that one. Okay, let me go down.
Cool.
How many did you send?
There are 3 photos, I think.
Okay, I got all 3 of them forwarded.
Okay, cool.
All right. So that should give us material to work on here.
Okay.
Let's see. Do we want to start here, or should I look at my email and see if I got the others? I think I did.
Yeah.
Others.
Yeah, probably the other.
There's one on them.
Others.
Okay, there's looks like some good stuff. What are you doing with integral signs? That's not from you.
Yeah. No, that's not for me.
Oh.
What? Oh, that's weird.
Weird. Yeah. No, I'm not sure where that came from. One of my calculus students, but when they must have sent that to my phone a while back.
Yeah.
So what do we have? We have this one, and same one. So far I've only gotten one.
That's weird.
Well, the other one will come through. I'm
okay.
worried about it. Let's start here. Which problem?
56.
Okay.
Yeah, 56.
What is theorem 811?
Yeah.
What is theorem? Proving theorem. Oh, okay. I guess I can figure it out here. ABC is a rhombus. We're trying to prove that AC is perpendicular to BD. And plan for the proof is ABCD is a parallelogram. Its diagonals bisect each other. Because of that. And show that triangle AXB, this triangle right there, is congruent to triangle CXB, which is this triangle here. And once we've shown that they are congruent, then we're going to show that AC and BD intersect to form congruent adjacent angles. In other words, all four of those are 90 degrees.
Yeah.
And that comes from, there is a theorem called the perpendicular intersector theorem or something, where if you have two lines that cross and they're perpendicular, you create four angles.
Okay.
In other words, if these are perpendicular, you create four angles that are 90 degrees. What we're going to prove is the converse statement of theorem 811.
Okay.
Which is that if we find four 90-degree angles, we're going to prove they're perpendicular to one another.
Okay.
Trying to prove perpendicularity, so we're going to figure out that these are 90-degree angles. Now the question is how?
Yeah.
Well, first of all, let's show that AXB is congruent to CXB. Let me draw this.
Okay.
I can always work a little bit better with this stuff if I'm working my drawing, I think.
Yeah.
So this is a parallelogram. Oh, excuse me. This is not a parallelogram. This is a rhombus.
Quadrilateral, right? Yeah, rhombus.
What's a rhombus mean?
Rhombus is like four equal sides. Four sides that are congruent to each other.
All four sides are equal. Okay.
Yeah.
And now we're going to connect with diagonal.
Okay.
To form four triangles.
Okay.
And we'll label them. I always mean to write bigger here.
No problem.
I get myself to do it. So let's see. How are we going to do this?
Let's see.
Because it is a rhombus. Because ABCD is a parallelogram. Where was that given? Because what they say given is ABCD is a rhombus.
And then it says there.
I guess all rhombuses are parallelograms.
I guess so, yeah.
Yeah, if you think about it, I can't draw four sides. In other words, if I draw two sides that are equal, and then I try to draw the third side over there, there's no way the fourth side is going to be equal. So the only place I'm going to be able to draw the third side is on a line like that, connecting it to that. So rhombuses are parallelograms.
Interesting.
Okay?
Okay.
That's how we're going to prove this triangle is congruent to this triangle. Because if the secret with parallel lines, and I mean this, is to pull out the transversal that you're interested in.
Okay.
Okay?
Okay.
In other words, we've got two sets of parallel lines here. We got AB is parallel with DC. We got AD is parallel with BC.
Yeah.
So that tells me a lot about the angles. Let's label some angles here.
Okay.
1, 2, 3, 4. Notice that labels the congruent angles that we're looking at. Just a second here.
Okay.
So we know that 1 is equal to 4.
Mm-hmm.
because of the transversal AC between the two
Okay.
horizontal parallel lines.
Okay.
And we know that 2 is equal to 3
Uh-huh.
for the two parallel lines that are AD parallel to BC.
Okay, yeah.
Okay? So we know
Okay.
1 is equal or congruent to
Uh-huh.
4, and 2 is congruent to 3.
Uh-huh. Yeah.
And
Let's see.
think for a moment.
Yeah.
Prove congruency here. We may have to prove different congruence. In other words, if I try to directly prove this triangle is congruent to this triangle,
Yeah.
I have side, side,
Uh-huh.
and side. In other words,
Yeah.
BX is common to both of these upper two triangles.
Okay.
But side, side is not enough.
Uh-uh.
We need an angle. Now, we know side, side, so what I really want to prove is that that angle is the same as that angle.
Okay. Yeah. Exactly.
But let's see. If I know that this angle here is congruent to this angle here,
Uh-huh.
and I know that 1 is equal to 4, so I know that AXB is congruent to DXC.
Okay. So
Right?
AX yeah, so AXC is congruent to DXC.
Yeah, AXB,
Yeah, my
upper
bad.
triangle, is congruent to DXC because I have an angle and
Uh-huh.
I have that side, and I have that angle and that angle. So
Okay.
I have two angles and a side, and whenever you have two angles and a side, you know you have congruency. It's either
Yeah.
angle side angle or angle angle side.
Okay.
Okay, so I know this is congruent to this,
Yeah. Yeah.
and now
Um,
there's
so,
actually four other angles here that I can speak about. Let's
uh-huh.
label them 5, 6, 7, 8. In other words, those are also angles that are going to be applicable to the parallel lines. In other words, 5 is equal to 8,
Yeah.
and 6 is equal to 7.
Makes sense. Yeah, that makes sense.
Okay.
What, so 6 and 7, those would be alternate interior, and so would 5 and 8.
Let me think here.
Or just alternate angles.
If I'm next trying to prove that this is congruent to that,
Yeah.
then I'll know that this is congruent to this.
Okay.
Now, that's not going to be any easier for us. And notice who marked up this. Did you do these marks or did somebody else do?
Let me see, which one is it? Yeah, I haven't marked it up, no.
Alright, I see what I'm missing here.
Oh, are those pencil marks?
Yeah, but that's
I
okay.
just realized.
I'm taking the wrong approach here.
I just realized that, I'm sorry.
No.
I thought those were just like real marks, like part of.
I read the plan for the proof and I forgot this part of the theorem. If
Oh,
this is
okay.
a parallelogram, its diagonals bisect each other.
Okay.
Okay?
Okay.
And what that means is that this side is equal
Uh-huh.
to that side.
Okay.
Okay,
Yeah.
so now we have side, side, side,
Yeah.
right? In
Yes,
other
yes,
words,
yes.
there's
Yeah.
one side, there's another side, and there's the third side that are the same for those two triangles on the upper right.
Okay.
So that proves that AXB is congruent to BXC based on side, side, side.
Okay.
And so that's what we did there.
Uh-huh.
Now show that AC and BD intersect to form congruent adjacent angles.
Yeah.
Well,
So,
the congruent, I've marked this picture up so bad. Let me erase everything in it because I didn't need any of those angles because we proved it based on side, side, side.
yeah.
What I needed to know was the theorem that these two bisect one another.
Uh-huh.
Okay? So
Okay.
we got triangle 1 is congruent to triangle 2.
Okay.
And this is a common side among both.
Mm-hmm.
We know that that's equal to that, and we know that that, let me put double hash mark there, but we know that AB is equal to BC.
Uh-huh.
So based on congruency, we know that angle AXB has to be what? Angle
It
AXB has to be congruent to
to
angle what?
so angle AXB has to be congruent to what have to CDB
BX.
or BXC, my bad,
In other
yeah.
words, because these two triangles are congruent,
CXC.
this angle is equal to that angle.
Okay.
BXC.
Okay.
Okay? What else we know is that angle AXB and angle BXC are a linear pair.
Uh-huh.
And two angles that are a linear pair are supplemental, meaning they have to
Yep.
add to 180 degrees.
Uh-huh.
And
Supplementary.
AXB is equal to BXC. AXB has to be 90. BXC has to be 90. Because they're both 90-degree angles, AC is perpendicular to BD.
Okay.
There's your basic paragraph proof.
Awesome. Cool.
In other words, you don't have to, they're not asking for a two-column proof. They're pretty much just asking you to explain how you're proving it. So
Uh-huh.
let's have you go back over that and explain to me what we did.
Sure. So we proved that ABC is rhombus by saying that AXB is congruent to DXC, which is the ASA postulate.
Hold on. Let's go back
Yeah.
a moment.
Okay.
Rather than referring to these triangles by letters, because it's hard sometimes to tell the difference when you're saying B, C, or D, for me,
Uh-huh.
let's talk about triangle 1 and triangle 2.
Okay, so we said
The
that
goal is going to prove that those two are congruent. And at the moment, the only information we have is that it's a parallelogram. Well, actually, it's a rhombus, which means that side is equal to that side.
Okay.
And we can see that common side, so there's a second side that it has to be the same between these two triangles.
Okay.
So what additional piece of information or theorem do we need to prove congruency?
So we know that angle 1 and angle 2 are congruent to each other.
Hold on.
So don't we?
No.
Yeah.
Not yet. That's not angle 1. That's triangle 1.
Or triangle 1,
And
my bad.
triangle 2.
Okay.
And at the moment, as all we have determined is that we have two sides. That side's equal to that side, and that
Yeah.
side's equal to itself.
Okay.
Okay, we
So.
know that by definition of rhombus.
Okay.
Okay, now
Okay.
this piece of information right here, because ABC is a parallelogram, its diagonals bisect each other.
Okay.
So what's the next piece of information you can claim?
So they're diagonal to each other. We could say.
They bisect each other. That's the key.
Yeah. Yeah. So. Well,
What's equal to what if they bisect each other?
if they bisect each other, so like 2 would be. Or AD would be equal to 2.
Not AD. AD is not in one of these two triangles. Always only talk about these two triangles for a moment. We don't really care about these two triangles yet.
Okay.
Okay? These two triangles, at the moment, we only have two sides that are equal.
Yeah.
The one with the single hash mark and this middle one that is common to both.
Okay.
But we know these two diagonals bisect one another. What does that tell me?
That tells us that.
What is bisect?
Well, X is like it bisects BD and then it also bisects AC.
So what does it say about AX and XC?
That X is the midpoint.
What does it say about AX and XC? Those line segments.
That they're congruent to each other?
Yes. That's what I've been trying to get you to say.
Okay.
In other words, that's equal to that.
Okay.
Now, we can state that triangle 1 is congruent to triangle 2 based why?
Because the definition of
Which
congruency.
Which theorem?
Theorem 8.11.
No. There's 4 different ways to prove congruency. Which way is this?
The triangle congruency, so.
Why are these two triangles congruent?
Because of the SSS postulate.
SSS, exactly.
Okay.
Okay? Now that we have them congruent, what can I say? Remember, my goal is to prove that diagonal is perpendicular to that diagonal. And I'm going to basically do that by proving that each of these angles here are 90 degrees.
Okay.
Okay?
Okay.
Well, why would they be 90 degrees? First of all, this angle, and now let me go back here. And now that's angle 1 and that's angle 2.
Yeah.
Okay? Just to change in the middle of the ship. What's the relationship between those two angles?
They're supplementary to each other.
That's 1. So 1 plus 2 has to equal 180. What else?
We know that
because the two triangles are congruent, what do we know about 1 and 2?
We know they have to add up to 180. So they both have to be 90 degrees.
Well, hold on, you left out a key step. Because the two triangles are congruent to one another, what's the relationship between angle 1 and angle 2?
If they're perpendicular to each other?
Equal.
Equal, okay.
CPCTC, congruent parts of corresponding parts of congruent triangles are congruent. Well, this is the angle, the same angle that this is between these two triangles. In other words, I have, from parallel lines, I know that one is equal to that one. I've got congruency proved. Okay? When two triangles are congruent, all 3 sides are equal and all 3 angles are equal. In other words, this angle is equal to this angle.
Okay.
But most importantly, 1 is congruent to 2.
Which, yeah, that makes sense.
That's the piece
Okay.
of information we need. We got
Okay.
that from the fact that we're dealing with two congruent triangles. So
Okay.
if you were writing a two-column proof, this would come from CPC,
CPCTC.
CPCTC, yeah.
Okay.
The fact
Okay.
that one is congruent to two.
Okay.
Okay? This one comes from the definition of linear pair. Between these two,
Yeah.
one has to be 90 degrees and two has to be 90 degrees.
90. Yeah, because they both have to add up to 180.
They have to add up to 180 and they're equal. And the only way to have that happen is if they're both 90 degrees.
Okay.
Okay? Once you prove they're both 90 degrees, what does that give you? That final proof.
Yeah, it tells you that.
It tells you that those two lines are perpendicular.
Yep, exactly.
Based on the fact that when two lines intersect and form 90-degree angles, they are perpendicular. The theorem actually says that when two lines are perpendicular to one another, they form four 90-degree angles. That's what the theorem says.
Okay.
But they said, write a proof for the converse statement. Well, the converse statement is frequently called the corollary to that. Would be that if I have two lines intersecting and I know that that's a perpendicular angle and that's a perpendicular, if I know that those are each 90 degrees, then I know the two lines are perpendicular also. It works both ways. If you know they're perpendicular, they're 90 degrees. If you know they're 90 degrees, they're perpendicular.
Okay, cool.
All right.
Okay.
And I got another email here. That's probably my other picture that I sent to myself.
Okay.
Now, wow. It must just be the network is very, very slow today. Although this
must
be very fast, but I took two more of your pictures and forwarded them to my email, and they didn't come through.
That is weird.
That is weird. All right. Well, that's fine. We only have 12 more minutes today.
So yeah, 56 was the only one.
Okay, nothing else on here?
No, nothing else.
Okay.
What else could we work on?
Well, I've got this other document here that's from your classmate.
Okay.
She had me start on 19 and just go through this page and the next page. And I don't think we even got to my second page, which is this one. There's a lot more stuff on it.
Yeah.
But this looks familiar to you also?
It does, yeah.
Okay. Well, let's start here.
Okay. Okay, so name each quadrilateral, parallelogram, rectangle, rhombus, and square for which the statement is true.
Okay, so equiangular. Yeah. Which of those four objects are equiangular? Hold on a second so that I can write. And I'll draw some of them.
Okay.
That a little bit bigger. All right.
Okay.
Let's start with a rectangle. Is that equiangular?
Okay.
Is it? Equiangular.
Well, we don't. Yeah, we don't know. I don't think no.
What's equiangular mean?
That means like all sides that have to be equal distant from each other.
Not all sides, all angles.
All angles have to be equal.
It's not equilateral. Equilateral would be all sides are equal.
Okay.
Equiangular means is this angle the same as that angle, and the same as that angle, and the same as that angle?
Okay.
Is it for a rectangle?
No. Huh? Yeah. Yeah, it'd have to be,
All
yeah.
four angles are equal. They're all
How far?
four
Yeah.
equal.
Yep.
Okay?
Okay.
Let's look at a parallelogram.
Okay.
Parallelogram is like a rectangle, only not 90-degree angles, but these are all parallel. Those two sides are parallel, and these two sides are parallel.
Okay.
Are all four angles equal?
No. Well, just two of them are. Like the bottom and top.
Opposite angles are equal. In other words,
Yeah,
that's
exactly.
equal to that, and that is equal to that.
Okay.
Okay?
Okay.
Okay. Let's take the third thing, a rhombus.
Okay.
Well, technically, a square is a rhombus,
Uh-huh.
but if I draw the rhombus as a square, I'm going to find equiangular. In other words, all four of these angles are equal. So let's not
Okay.
draw it as a square. That'll be the last one, the square.
Mm-hmm.
But if I draw a rhombus as merely a four-sided figure that's equal sides,
Uh-huh.
we discovered that it's a parallelogram.
Yeah. Yeah.
But are
Makes.
all four angles equal?
Uh-huh. Well, it's just like a square, only like slanted.
Now, let me
So
draw it
like.
a little different. Let me draw it like this. Notice
Yes.
that is
That would
a
be.
parallelogram, but it's also a rhombus.
Yeah, exactly. And all sides are equal to
And
each
what we
other.
discovered from that last problem is that a rhombus is a parallelogram.
Uh-huh.
You can't draw a rhombus without it being a parallelogram. Now,
No.
if we look at this rhombus, are all four angles equal?
Yes. Like, yeah, they're all congruent to each other.
No. It's the same as the parallelogram answer.
Okay.
Opposite angles are equal, but that's obtuse, that's acute. There's no way those are equal.
Oh, that makes sense. Okay. Yeah, I was just looking at the
Sometimes
sides.
it
I wasn't
helps.
like.
If you have a hard time seeing this, just
Yeah.
exaggerate the parallelogramness of it.
Okay.
When I draw it like that, notice I still have a rhombus, but
Uh-huh.
now clearly that angle is not equal to that angle.
No.
Big
Yeah.
obtuse angle, that's a acute angle.
Uh-huh.
Okay? So
Okay.
frequently, the best way to decide these questions is to just draw them slightly exaggerated. Notice that when I drew my rhombus like a square, I couldn't tell.
Uh-huh. No.
I still have four equal sides, but I can't tell if it's equiangular or not. But when
Okay.
I drew it as a parallelogram, more of a parallelogram,
Uh-huh.
uh, of course a square is also a parallelogram, you know.
Yeah.
In other
Yeah.
words, there's things going on here that how you draw it is key. Always draw it exaggerated.
Okay.
In other words, don't draw your parallelograms like squares, draw them like parallelograms, like they typically look. When you take geometry, this is how they draw their parallelograms. They don't draw them like this.
No.
Okay, they draw them slanted
Okay.
so that it's obvious that it's not a rectangle or a square.
Okay.
Okay?
Yeah. Okay.
And for a square, is that equiangular, all four angles?
Square would. Yeah, square would be because they're all 90 degrees.
Correct, okay.
Yeah. Okay.
Which ones are equiangular? We've already been through the equiangular. How about equilateral?
What's the definition of equilateral again? So
All,
like,
all four sides are equal.
have to be equal. Okay, so that'd be a square.
Let's start with parallelogram.
Okay.
Do all four sides have to be equal?
Yes. For an equilateral, they have to be.
No. Hold on. Don't get confused here. We're just talking about a parallelogram. We're not talking about an equilateral parallelogram. We're talking about a parallelogram. In other words, I can draw my parallelogram like that.
Okay.
Only thing I have to have is opposite sides have to be parallel. They don't have to.
Okay.
In other words, clearly that is not equal to that.
Okay. Yeah.
Okay, so opposite sides of a parallelogram are equal. I know that's equal to that, but
Uh-huh.
that is not equal to either one, but it is equal to the opposite side.
Yeah, exactly.
So again, the secret is to draw the parallelogram in a way that is not this.
Okay.
In other words, when you encounter a problem like this and it says for which the statement is true, we'll try to draw it in a way where it wouldn't be true. In other
Okay.
words, take your parallelogram and see if I can draw a parallelogram that does not have equal angles and equal sides. And there it is right there.
Okay.
I could also have drawn that parallelogram like this so that it had equal angles and equal sides. But
Okay.
I'm not going to do that because I'm trying to find a situation that is not this.
Uh-huh.
In other words, if I'm trying to prove whether a rectangle is equiangular,
Uh-huh.
I'm going to draw it in a way to try to prove that it's not. Well, I can
Okay.
draw a rectangle like that. I can
Uh-huh.
draw a rectangle like that. But every way I draw it, no matter how I draw it, all four angles are 90 degrees. That's the definition of a rectangle.
Yeah.
Okay, so
Okay.
I cannot draw a rectangle without having it be equiangular. And
Okay.
that's what you need to do on some of these, is try to draw it so that it's not true. Okay?
Okay.
So we just
Kind of like ruling it out. Yeah.
We just proved that a parallelogram is neither equiangular or nor equilateral.
Uh-huh. Okay.
Let's take a rectangle.
Okay.
In other words, we want to take each of these four figures and put it through each of these questions.
Okay.
Is a rectangle equiangular? We already proved that it was. What about equilateral? Is it?
So, okay, so just like to be clear, so like an equilateral has like all equal sides, like four equal sides.
It's those words right there. Angular,
okay,
lateral. That means equal angles, that means equal sides.
So it wouldn't be equilateral because
correct.
Yeah, like the top and bottom would be equal to each other, but they wouldn't be equal to the sides.
Correct.
Yeah.
In other words, it's very easy to draw a rectangle or a parallelogram, a rectangle rather, that is not equilateral.
Uh-huh.
About a rhombus.
Rhombus would be...
We've already proven that it's not equiangular.
No. And it wouldn't be equilateral either.
Yes, it is. That's actually the definition of a rhombus.
Equilateral.
All four sides are equal. That's the
okay.
definition.
Just not the angles aren't.
Equilateral, but the main definition of a rhombus is all four sides are equal.
Okay. Just not like the sides.
Kite is not a rhombus.
No.
This side's equal to that side, but that side's not equal to the other. They're equal.
Okay.
In other words, adjacent sides are equal, kind of. But that is not a rhombus. For a rhombus can be a parallelogram. In fact, it is a parallelogram also.
Uh-huh.
It's a parallelogram that all four sides are equal.
Okay.
And we know that opposite angles are equal, but not all angles are equal. So it is not equally angular.
Yeah. I was just thinking of like the sides, because the sides aren't equal to each other. Just the.
Finally, a square. Is it equilateral?
Yeah.
Okay, cool.
Yeah.
Let's talk about 21.
Okay.
Well, we don't have much time to talk. It's 10:49. Why don't we stop there at 21?
Okay.
And,
no problem.
And it looks like I've gotten a couple of emails in. No, just appointments. Where are my...
Okay.
Boy, what is going on with my... I sent those from my phone, and they still didn't get received. So there must be something going on in the system.
Yeah. Yeah, there has to be.
All right.
It just doesn't make sense. Yeah.
So let's see. Your Monday appointment is for 6:30, not 5. That was
Okay.
your mother's request. She said you had something going on at 5
Yeah.
tomorrow, so
Yeah.
6:30 tomorrow night. And
Okay, cool.
hopefully by then, give it another shot trying to send me material.
Yeah, I'll
Not
try to.
tonight, but sometime before your 6:30 meeting tomorrow. Try
Okay.
to send me what else you want to work on.
For sure.
Okay?
Awesome. All right. Well, thank you. Appreciate that.
All right. Talk to you tomorrow.
All right, cool. Sounds good.
Bye.
All right. Bye-bye.